Hi, Assalamualaikum. So today I'm going to present about my final project. So my name is Nusyaira binti Muhammad Fendi and my title of the project is about social distancing monitoring system using deep learning supervised by Associate Professor Dr. Emilia Ritahani. As everyone knows, COVID-19 has been declared a pandemic in the world since 2020. World Health Organization suggested that one way to prevent the disease from spreading is by keeping the safe distance at least 1 meter from other people. This project proposed the object detection using a deep learning approach that can help the authorities to monitor social distancing in crowded places. This system will be using the existing object detection architecture, which is YOLO V4 for the person detection, and the result is further compared with other two models, which are faster RCNN and single shot detector. Based on the local news, there has been reported that most citizens have failed to observe the social distancing, and the numbers of SOP violators in the premises keep increasing. In addition to that, authorities' inspections still need the manpower to do the observations. So, the objectives of this project is to develop a social distancing detection and monitoring system based on the deep neural network. And the second one is to evaluate the object detection model performance and finally further compare the detection model performance for different models. A social distancing detection system requires an object detection system that can detect a person automatically. A lot of previous studies has been carried out for the person detection. In 2018, Lan et al. Has used YOLO-R, which is the improvement of YOLO V2 model for pedestrian detection. In 2020, Pan et al. Has used faster RCNN single shot detector and YOLO V3 for social distancing detection system. Finally, Yang et al. 2020 used faster RCNN and compare it with YOLO V4 model for detection system. This project chose three architectures to be analyzed, which are faster RCNN, single shot detector, and YOLO version 4. This three model is based on convolutional neural network that is best suited for image processing. Faster RCNN is a two-stage method where the first stage is for rigid proposal network that use CNN instead of selective search like the previous version of RCNN. The second stage is the classifier that includes the ROI pooling and the output. Next is single shot detector or SSD. It is one stage detector that uses CNN as the feature extractor and detection. And the third one is YOLO version 4. YOLO uses single convolutional network that predicts the bounding box and the class probabilities for these boxes. YOLO V4 is the improvement for the previous YOLO version that consists of 4 blocks. Backbone block refers to feature extraction architecture. Next is to add extra layers between the blocks. Head, which comprise dense prediction and sparse prediction, is to locate the bounding box and to classify what is inside each box. Methodology for this project is based on machine learning process that starts with project planning. Project planning includes the review of the previous works. And the second one is data collection. The data has been taken from Microsoft Common Object in Context image dataset for person category. The third one is data preparation that includes the annotation of the bounding box and data splitting for training and testing set. The fourth one is data modeling. The model has used the transfer learning from the existing architecture for YOLO v4, single shot detector, and faster RCNN. The fifth one is model evaluation that uses 20% from the data for testing purpose. Finally, the result analysis, where the results are being analyzed by calculating the mean average precision for accuracy and frame per second for model performance. The tools used in this project is Python. Second one is OpenCV for computer vision library, TensorFlow for model API, and the fourth one is Google Colab. This is the Google Colab for social distancing detection application for YOLO version 4. The numbers indicate the frame per second to show how fast the model can detect in 1 second. This is the example for the test video for the application, and the red box indicate that the person is less than 1 meter with others, and the green box indicates that it is more than 1 meter with others, and the risk percentage is calculated for each frame. In model testing, YOLO v4 has achieved a MAP score of 82.47%, while faster RCNN is 66.1% and SST is 41.34%. A good detector for object detection should give the best balance for speed and accuracy that is needed for the application. Although SST has achieved the highest FPS of 49 to 54, but it shows the lowest MAP score among these. To conclude, YOLO v4 has proven to be the best detection model where it shows a balanced accuracy and speed for detection and has been applied for the monitoring system. Figure 2 shows the excerpt from the test video where the person with violated distance is annotated in red and the risk percentage for each frame is calculated. Next is figure 3 where it shows the graph that display the risk percentage for each frame for the test video. In conclusion, YOLO v4 has been chosen to be implemented in the system as it produced the best MAP score compared to the other detection models with a balanced speed. The calculation of social distancing detection did not use proper camera calibration, and the distance is based on the assumption and may lead to the inaccuracy for the social distance. Next is the alert system can be included in the system for future works to improve the social distance monitoring for the authorities. That's all for my project. Thank you.